We want to now look at how do we derive the government expenditure multiplier in the Keynesian cross using geometric series. So to analyze this, we will look at how the total effect on output or income from government purchases arises because of the initial change in government purchases delta G, because of the first change in consumption MPC times delta G, the second change in consumption MPC square times delta G, the third change in consumption MPC cube times delta G, and so on. So we can write the total change in output, which is delta Y equal to delta G plus MPC times delta G plus MPC square times delta G plus MPC cube times delta G plus so on. So now on the right hand side, if we factor out the delta G, so we have delta Y is equal to delta G into 1 plus MPC square plus MPC cube plus so on. Now in the brackets, when we have 1 plus MPC square plus MPC cube plus so on, this is essentially a geometric series where the first term is 1 and the common ratio is MPC, where this common ratio, which is equal to MPC, we know lies between 0 and 1. So we have this geometric series for which the common ratio is between 0 and 1. So this geometric series converges and it's sum to infinity, which is what's given in the bracket to us as 1 plus MPC square plus MPC cube plus so on, is going to be given to us as 1 by 1 minus common ratio, where the common ratio is MPC. So the sum to infinity given in the brackets of this geometric series is essentially just 1 by 1 minus MPC. So I can replace 1 plus MPC square plus MPC cube plus so on in the brackets with 1 by 1 minus MPC. So we get delta Y is equal to delta G times 1 by 1 minus MPC. Now in this case, delta Y by delta G is essentially the government expenditure multiplier, which in this model is 1 by 1 minus MPC. It tells us that if government spending increases by $1, by how much will output or income change?